All right. And we're live. Excellent. Back once again to an empty classroom with a bunch of digital avatars floating around the screen or some junk like that. I don't know. Oh, goodness. That's where we're at. It's only day 3 of this thing. Slowly losing my mind. Nah, that's not possible. That's not possible. You can't lose what you didn't have. But anyway, I digress. While people are filtering in, because I give them a few moments to kind of do so. Oh, sorry, I'm getting messages all of a sudden. That's weird. Oh, it all dropped down to like 3 people in the chat. What's going on? There's like 20 people in this class. I don't know. But I'm going to give people a couple minutes to kind of get in, and then I will talk about what my expectations for today are going to be. So give me one moment while I set something up, and then we will talk about what's going on. Okay. So still only have 3 people. But yes, I was going to ask. Genesis is actually down today. Genesis is down. The network for the computer logins are down. Or for some of the computer logins are down. Meaning teachers can't access stuff that's on their computer desktops. Like they can't access their files and whatnot, which is just so much fun. Let me tell you, the technology issues today have been hilarious. But yeah, like I said, you're going to have to leave a comment in the chat indicating your presence. They're actually asking, because Genesis is down, they're actually asking us to like make a paper copy of the attendance or something. So again, it's vitally important that you do make the comment in the chat, and I will remind you before the end of this class period. So we have less than 2 weeks until midterms. Supposedly, you're going to be back in the classroom for midterms, but that remains to be seen, especially with the COVID numbers still climbing. So it's a we'll see situation. In Google Classroom, I had to, unfortunately, assign you a benchmark. I'm so frustrated at the benchmarks this year. But if you read my explanation, you'll see that it will benefit you to knock out that benchmark for me to the best of your ability. That would actually be incredibly helpful. It would be. So please make sure that you do that before the due date. But make sure you read the instructions for it. As for today, I have today and Friday to wrap up what I wanted to do before midterms. And then next week, I have you on Wednesday, Friday again, in order for us to review for midterms. It says there's only 5 people in the chat. Now, first of all, 6 of you commented, but there's way more than 5 people in my class. That's just strange. Anyway, as for today, as I said, we are going to be continuing with what we've been doing. I'm going to pick up where we left off with nth roots. So if you do not already have them out, I'm going to need those notebooks out and open. So, like I said, I'm going to pick up where we left off in your Google Classroom. And I'm kind of showing you this so you know it's there. On January 11th, Monday, I posted 2 worksheets I'm going to be picking off problems off of the 6.4 side of that worksheet. So if you do want a reference, for the problems that I'm working on, then please, by all means, do that. That'd be great. In the meantime, as I said, with those notebooks being out and open, I'm going to pick up with some examples to show you exactly what is expected of you today. Let's see what we got here. Come on, where's my pen? There it is. Today is the 13th. And I am calling this, you can't see what I'm writing. I'll fix the camera in a moment. I'm calling this nth roots continued. Nth roots continued. Now, I am going to be walking you through some very specific details to help you understand something that you're going to need for later on in this chapter. Some of the things that I'm going to be going over may seem quite tedious, but trust me when I say that there is a rationale for what I'm doing. Let's start off very simply with this, the square root of x squared. Now, I am going to be very deliberate with the way that I'm speaking today, mainly because I need you to understand, number one, the gravity of the material that I'm introducing to you. We're not introducing to you, but whatever. But more importantly, understanding the nuances for simplifying certain problems to get to the answer. Now, we know what the square root does. We know what an x squared does. But that's not the point. A square root is nothing more than an exponent of 1/2. In fact, I introduced this to you way earlier on in the chapter. I probably introduced this to you before winter break, and I tried to re-emphasize that during this class period. I'm going to write something on the board in a moment. But a square root is nothing more than a 1/2 exponent. Now, this has huge implications for what we are going to do today. Last class, I wrote down something for our notes, which looked like this. A to the m over n power. I'm writing it off to the side because I want to keep it there for the duration of this class period. But it's a to the m over n power. And what I told you to remember about that fractional exponent was that m over n could be written as power over root. Power over root. In fact, I could rewrite this entire problem by taking the nth root of the value of a and then raising it to the m power. So now I'm looking at something like this, a square root. Remember, the bottom of the fraction is the root that you are taking. So this square root, I'm replacing with a 1/2 power over root. Understanding that concept is going to be paramount to understanding what I'm going to be showing you today, because I'm going to be going into some really nice detail. Now, a direct consequence of square root turning into a 1/2 power is the fact that we can now multiply power to a power with our exponent properties And because we can multiply power to a power, 2 times 1/2 technically cancel each other out to give you 1, leaving you with just an x. Now, it just seems silly to kind of go through all of that detail when in reality, people be like, yeah, the square root of x squared, the square root and the x cancel each other out, leaving you with the x. I know. But there's something else going on here. There's something deeper that you have to understand towards understanding the types of problems that I am going to throw at you. Let's take another step. Let me show you something that we are all very aware of. The square root of 64. We know what the square root of 64 is. You've known that for a long stinking time. But that's not the point. The point is, as I've said, I want to go a bit deeper. Why is the square root of 64 equal to 8? Well, Mr. Markey, because 8 times 8 is 64. Yes, I agree. That's not exactly the direction that I'm going, but 8 squared is indeed 64. Let me change this. Make sure that you can see that. Yeah, you can see that. 8 squared is indeed 64. Oh, then by the logic of the first line of work, I can change that square root to be a 1/2 power. And because I can change that square root to be a 1/2 power, you multiply these two exponents together, they cancel each other out, leaving you with 8. The square root of 64 is 8. We know this because 8 times 8 is 64. But this line of work is a mathematical fact. This is the mathematical rationale behind the square root of 64 becoming an 8. This is the actual proof behind that. Now, how that comes into play, well, let me pick a problem from that worksheet that I talked about. How in the world does that apply to some of the problems that I have in store for you? I just put a problem on the board. I want you to write that into your notes. Of course, the negative 4th root of 256. I don't know that many people that know the 4th root of 256 off the top of their heads. I don't know that many people that do. Some do, not all. Mostly none. Now, I could type this into the calculator and just see what happens. I don't know. I mean, there's a negative out front, so it's just going to multiply the answer by a negative. But let me find out the 4th root of 256. There we go. In the calculators that you guys have on your Chromebooks, you have an option to take a 4th root. If you click Math and go down to the option that says X root, you could change it to the 4th root of 256. Which is nice. Oh, it's 4. Oh, I wonder. Times 4 times 4. Yeah, I guess that did work. 4 to the 4th power is indeed 256. Interesting. I guess we have our answer. Yes, we do. I mean, with the negative out front, of course. But again, we need to take it a little bit deeper in order to understand what I'm going to throw out at you. I'm looking at this problem, and we need to realize, based on the calculator right here, 4 to the 4th power is 256. Well, I can rewrite this as the fourth root of 4 to the fourth power, because I just showed on the calculator that 4 to the fourth power is 256. Nice. As a result, based on everything that we've done prior to this, now I'm not going to actually change the exponent, but that fourth root is in reality a 1/4 exponent. It's 1/4 exponent. And as a result, that 1/4 exponent cancels out that fourth power. And when they cancel each other out, you are left with the negative and the large 4 that was on the inside. These are the types of things that we're going to need to recognize. Now, like I said, I am going to be taking this a bit farther today. Mr. Markey, why can't we just use our calculators for all of these problems? It just makes more sense. Answer: because your calculator's not always going to give you what you want. Let me show you what I mean. Your calculator is not the saving grace that you think it is. There's an example that I'm about to show you. And then after I show you this, I am going to attempt to put it into the calculator and see what happens. Here's the problem. The fifth root of 243 times x to the 10th power. The fifth root of 243 x to the 10th power. Now this is a problem where if I attempted to type it into the calculator, it would not give me the correct answer. Let's see what happens. Flip. Clear. The fifth root of 243 x to the 10th power. Okay, let's see what happens. That is not the answer. You could try to write it down, but it's wrong. So how do I do it? Well, there's a few different things that we can do. Over the course of the next few problems, I'm going to be showing you varying techniques as to how to handle a problem like this. First, I got to deal with that 243. 243, what the heck? Let's try to do prime factorization to 243. You ever do those number trees where you break a number up as far as it can possibly go? I mean, I know I have. But let's take 243 and let's try to break this thing down. Now, what do I divide it by? Can't divide it by 2. Let's try dividing it by 3. Oh, yeah, look at that. You can divide it by 3 again. And again. And again. And again. Interesting. After a few moments, it should be pretty clear to recognize that 3 to the 5th power is 243. Oop, one too many. Delete that. There you go. Now that's going to be incredibly helpful towards what we need to do. Let's try to rewrite the problem. I'm going to take this problem, I'm going to rewrite it as the fifth root of 3 to the 5th power times x to the 10th power. Now we're on our way. According to what I did with the fifth root, or I'm sorry, with the square root and the fourth root on the previous page, I could theoretically rewrite the problem like this. Because the fifth root, power over root, is nothing more than a 1/5 exponent. This is why we spent a lot of time talking about exponent properties. This is why I needed to take the time with this process today to eventually get to something like this. Now, this method that I'm showing you may not always work. And in fact, I'm going to be showing you alternate ways to handle these problems. But this, there are two things being multiplied on the inside. I'm going to take this 1/5 exponent and I'm going to distribute it to the exponents. Am I allowed to do that? Short answer, yes. You are allowed to distribute that exponent as long as there is a multiplication or division on the inside of the problem. If there was a plus sign or a minus sign, sorry, can't do it. But here you can. And again, doing this the long way, this is 3/5 now to the 1/5 power times x to the 10th to the 1/5 power. You don't always have to take this long, arduous route to get to the answer. But I'm doing this on purpose. I'm doing this on purpose to show you the types of methods that you could apply to these problems. Now, if I do power to a power on the 3, oh, look, they cancel. 5 times 1/5 gives you 3 to the first, which is just 3. And then 10 times 1/5, well, that just gives me a 2. That is the answer. 3x squared. There are different ways. Oh, sorry, my wife just texted me, and that was funny. Anyway, I'll tell you about that later. There are different ways to handle this problem. Many different ways to handle this problem. What I just showed you was a very drawn-out way. There are shorter ways, and hopefully you will see those shorter ways on some of the subsequent problems that I have in store for you. Let's try a messed up one. I love messed up problems. Let's try a really messed up one, attempting to apply some of the methods that we've seen so far, but I'm going to introduce a slightly new method to you. Let's try this one. Example. Third root of negative 64 r squared w to the 15th. Let me zoom in on that. The third root of negative 64 r squared w to the 15th. Now, there's something strange going on here. Something incredibly strange going on here. First of all, 64 is a perfect square, but this thing is asking me to take a cube root. Ugh. Again, there's another r squared in there, but again, this is a cubed root, and there's a negative in there. There are technically 4 terms in this problem. The negative, the 64, the r squared, and the w to the 15th. Where do I start? What the heck? I thought you couldn't take the square roots of negatives. Correct. You can't take the square root of negatives. But this is a cubed root. Let me go to my calculator real quick. Let's see. -1 times -1 times -1 is indeed -1. The cube root of -1 is -1. You can take cube roots of negatives. If you treat it as a -1, it'll just pop out as a -1. That's kind of nice. What about the 64? Well, if you did a prime factorization of 64 in the calculator, you could quickly come to the conclusion that 2 to the 6th power is 64. 2 to the 6th. Now that's going to be helpful. That's going to be incredibly helpful. Oh, let me type something else into the calculator. Check this out. 2 times 2 times 2. 2 times 2 times 2. Look what I just did here. I grouped them together as 2 cubed and 2 cubed. That's incredibly helpful. Now, that will come into play on the next problem. But for this problem, I'm going to do something slightly different. First, let me take some of that information and let me kind of mess around with it a little bit. First, there's the cubed root. But now let me break up those 4 pieces. -1, 2 to the 6th, r squared, w to the 15th. I haven't changed much, except I separated the -1. I changed the 64 to a 2 to the 6th, and I left everything else the same. Now, technically, because everything is multiplication on the inside, I am allowed to do the following. The cubed root of -1, the cubed root of 2 to the 6th, the cubed root of r squared, and the cubed root of w to the 15th. Technically, I am allowed to do that because a cubed root is nothing more than a 1/3 exponent. And I can distribute that 1/3 exponent to every term. Again, as long as there's multiplication separating everything. If there was addition or subtraction in there, oops, can't do it. Now check this junk out. This can be rewritten as 2 to the 6th to the 1/3. This can be rewritten as w to the 15th to the 1/3. And the reason why that is important is because you can multiply together those 2 exponents. And this comes out as 2 squared. And this comes out as w to the 5th when you multiply, oh, you can't see it, when you multiply those 2 exponents together. Now, I've already shown you that the cubed root of -1 is just -1. I showed you that on the calculator. But what happens to that r I mean, I could rewrite it, but here's what you got to know. The only way that you are going to escape a third root is if you have an exponent that is a multiple of 3. Let me repeat that. The only way that you are going to escape a cube root is if you have an exponent that is a multiple of 3. Same thing with a square root. The only way you're going to escape a square root is if you have an exponent that is a multiple of 2. The only way you're going to escape a fifth root is if you have an exponent that is a multiple of 5. Unfortunately, that r squared cannot escape. It can't. It's stuck. It is behind bars. Sucks to be you, r squared. Here's what the answer actually is. As a result of everything that we've done, the -1 and the 2 squared become -4. The w to the 5th is allowed to be written on the outside. And the third root of r squared is stuck. As terrible as that looks, what I just wrote is the answer to this problem. It is the simplified answer to this problem. There are certain terms that are and are not allowed to escape the radical. They have to have the proper exponent depending on what type of radical it is. Sucks to be that r squared. Let's take it a little bit farther. Now, when I was doing this lesson for my 8A classes, I knew that I wanted to show them something extra. So I made up a problem that exemplified everything that I needed and hopefully will clarify everything I just showed you on the previous problem. Example. 4th root of 32 x to the 8th y to the 6th. Let me zoom in on that. I really feel like I'm doing ASMR today. It's very relaxing. The 4th root of 32 x to the 8th y to the 6th. Now, with a problem like this, there's a few things that we need to recognize. First of all, that 32, I got to break that thing down. That 32 can be broken down as 2 to the 5th power. As you can see right there, it shouldn't take that long to figure that out. 2 to the 5th power. But watch what I'm about to do. About to mess with your heads. 4th root of 2 to the 4th, 2 to the 1st, x to the 4th, x to the 4th, y to the 4th, y to the 2nd. I'll bring that down a little bit so it's not in the glare. There we go. Now, what the heck did I just do? I just did something incredibly important. First of all, I verbally mentioned that 32 was 2 to the 5th power. That is 5 2s being multiplied together, 5 of them. So what I did was I grouped together 4 of them, and I left the last one on its own. That's this right here. According to the exponent properties that we have done, I could combine these by adding their exponents together to make it 2 to the 5th. And like I said, 2 to the 5th is 32, but instead I'm working backwards. I'm going to repeat something I said for the previous problem. But instead of third root, I'm going to say fourth root. The only way that you escape a fourth root is if your exponent is a multiple of 4. The only way that you escape a fourth root is if your exponent is a multiple of 4. Well, here's the thing. 32 is 2 to the 5th power. Sorry, it doesn't have the right exponent. However, I can take that 2 to the 5th power. That's 2 to the 5th power. You can't see all of it. I'll put the other 2 over here. There it is. Good. I can take that and I can put together 4 of them to give them the proper exponent here. And I can leave the extra 2 just kind of sitting out by itself over there. I can do the same thing with x to the 8th power. X to the 8th power is x times, well, I'll put it outside the glare. I don't want it in the glare. Over there we go. X times 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 x. There's 8 of them, but I can split them up 4 and 4 because the only way that you escape a fourth root is if your exponent is a multiple of 4. Now, yes, I could have left it as 8, but I'm doing this for visual purposes. The y to the 6th, same issue. There's 6 of them. But the only way that you escape a fourth root is if you have an exponent that is a multiple of 4. So I split up the y's because these 2 exponents add up to 6. It's perfectly legal, but I got that one there. Now, in terms of this whole escaping the radical situation that I keep harping on, let's see what happens. This 2 to the 4th power would be raised to the 1/4 power, canceling out that exponent, leaving you with a 2. The same thing would happen to this x. The same thing would happen to this x. The same thing would happen to this y. Unfortunately, this 2 did not have the proper exponent. This y did not have the proper exponent. As a result, here are the terms that were allowed to escape. It was a 2 and a couple of x's, which are multiplied to give you x squared and a y. And then under that fourth root, that 2y squared is left behind. Sucks to be that 2y squared. These processes are so important. Each problem that I've done today, I've done slightly differently. And that's because there is no one way to get this stuff done. There is no one way to solve these problems. You have to look at what you have using legal mathematical steps and see what works. I have one more problem to show you. But let me talk about this very briefly. At the beginning of the year, I gave everybody an article, Finding the Glory in the Struggle. It's my philosophy on math. The question is, Marky, when are we ever going to need this? Well, I'm going to be completely honest with you. What we just did on paper right here, you're not going to do this in real life. You're not going to do this in real life. Sorry. But here's the deal. Mathematics is the only subject that refines and strengthens your problem-solving skills. What type of problem am I faced with? What type of methods do I know that could apply to this problem? Are my methods good enough to solve this problem? If my methods are good enough, then so be it. If they're not good enough, what do I have to do in order to solve said problem? This is a math problem. This is a life problem. It doesn't matter what the problem is. Do you have the skills and the resources to solve it? If you do, great. If you don't, what are you going to do? You can't just sit there and hope that the problem solves itself or hope that somebody solves it for you. You have to push yourself to figure out the methods to solve said problem. When I first bought my house, within a week, the hot water heater was spewing out brown water. We don't have the money to buy a new one right now. We just bought a house. So what do I have to do? I don't have the skills to repair a hot water heater. I don't have the money to hire someone. So I have to figure out how to maintenance and maintain this hot water heater in order to provide for my family. That's a math problem. I didn't have the skills. I had to learn the skills and then apply those skills to said problem. Mathematics is the only subject that refines your problem-solving skills. You are faced with abstract concepts, and you are taught the skills to solve them and to get them done. It is a puzzle. And if you can refine those puzzle and problem-solving skills, if you can refine them, make them stronger, that is going to bleed over into life when you are faced with real problems. I see this problem. This is the last problem I got for you today. After this, I'm going to wrap up, and we're going to go on our merry way. It's a square root problem. A lot of people look at this problem and they're immediately like, oh, the square root of x squared is just x, and the square root of 25 is just 5. Yeah, but that doesn't always apply to these problems. Here's the thing. A square root is nothing more than a 1/2 exponent. And since a square root is a 1/2 exponent, I could rewrite the problem like this. Rewriting the problem like that shows you why it's not as easy as you think. You are not allowed to distribute that exponent. You are not allowed to distribute that exponent. That is an illegal math step. You can't do it. Why, Mr. Markey? Why? Because there's addition on the inside of the problem. As I've said multiple times before, you can only distribute that exponent if there is only multiplication division on the inside of the problem. But since there are plus signs, you can't do it. You're not allowed to. So what does one do? I guess we're done. I guess I can't solve said problem. No. Since the beginning of this school year, we have been dealing with the type of problem that is on the inside of these parentheses. That is a quadratic. X squared plus 10x plus 25. That is a quadratic that we have solved in the past, a quadratic that we have graphed in the past, and more importantly, a quadratic that we have factored in the past. You see, that quadratic is indeed factorable. It can be factored into two binomials. The binomials of, well, x plus 5 times x plus 5. The reason why that works, and you could use the Tucker method, you could use whatever method of factoring that you've been taught in the past, but the reason why that works has to do with multiplying 5 times 5 and adding 5 plus 5. I put the brackets around there to kind of distinguish parentheses from the other. Okay, Ms. Markey, how does this help us? Well, x plus 5 times x plus 5 is nothing more than x plus 5 squared. Notice what that 1/2 power has done the whole trip down. That 1/2 power has just been coming along for the ride as you simplify what is on the inside of the parentheses. Well, now we're back at the beginning. Now we're back at the very first thing I showed you today. 2 to the 1/2 power. You're allowed to multiply those exponents together, and they cancel each other out. And when they cancel each other out, you are left with the final part, or the final solution to this problem. Now, we still have Friday to get practice with this stuff. And of course, I am going to be throwing something at you on Google Classroom. I will remind you that there is a benchmark needing to be done. All that information is made available in the Google Classroom classwork stream. Again, there's an explanation in there. Read the explanation. Not a fan of benchmarks, but that's the situation that we're faced with. Next week, I do plan on reviewing for that midterm. Of course, you know you have Monday off, right? You have Monday off, so I'm going to see you again on Wednesday, Friday. Finally, if you have not left a comment in the live chat, I'm going to need that done for attendance purposes because Genesis has been down all day. Technology has failed most people today. That's why I do my math by hand and in pen. I know. Keep in mind. No, are you referring to the stuff I taught you today or the benchmark? Because I would agree with you on both parts, but I just want to know what I'm referring to. I would agree with you on both parts, but I just want to know, is it this stuff or is it the stuff on the benchmark? Because your answer to that question is going to determine what I say next. Okay. I don't know what she hasn't said anything yet. She might actually respond in the middle of me talking. But let's assume for a moment that you were referring to the stuff that's up here. Ooh. Yes, but both. Okay. If the reference is to the stuff that's up here or the stuff that we've done today, yes, I totally get that. I get it. The first time you learn something, it's not going to make complete 100% sense. It's not. When my kids were learning to walk, first thing they did was face plant. Look at them now. I'll talk about the benchmark in a moment, yeah. But when you first learn how to do something, it's going to be challenging. You're going to make mistakes. I remember, different story, when I first had to try and fix our washing machine. I don't know how to fix a washing machine. You could watch all the tutorials that you want, but until you're actually in the middle of attempting to fix the washing machine, it is a different beast unto itself. And I remember that it took me multiple days with that washing machine half full with water because it wasn't draining. We had an HVAC that I was able to suck out most of it, but it wasn't good enough. So I had this washing machine tilted on its side because the casing was not designed to come off this thing. And I had to figure out why this thing was not draining. And eventually, after a couple of days of meddling around with it, because I still had to go to work, but after a couple of days of meddling around with it, I eventually found the compartment that was holding one lone baby sock that had been eaten up terribly, that was blocking stuff from draining. My wife took that baby sock and she actually framed it for me in a shadow box in the laundry room. I thought that was very sweet of her. Just as a reminder, when you first learn how to do stuff, it's going to be difficult. It will. It does get easier over time. In regards to the benchmark sucks. It does. The benchmark sucks terribly. I didn't design it. I'm not forcing you all to take it. My supervisor is basically saying, hey, everybody needs to take this. Okay, they're going to do terrible. It's on material that's way advanced and on stuff that I'm never actually going to teach in Algebra 2. Oh, but give it to them anyway. Okay. That's why I'm saying read the explanation in Google Classroom. Read the explanation that I gave you. It's a completion thing. Try your best, but if you don't get it 100% of the way, don't worry about it. The benchmark, that is. I'm going to sign off. If you guys have any additional questions, email me, of course. And I'm going to be probably in meetings the rest of the day. But hopefully I'll be able to catch up on emails once the network is back up and running. I don't know. I feel like this is my therapy session where I get to speak out stuff to you guys because there's nobody here and I haven't talked to people in like 2 days. Losing my mind. Anyway, I'll see you guys soon. I'll see you on Friday, maybe, in my mind. But like I said, bye-bye, bye-bye. Take your stuff. Bye-bye, bye-bye. Get out. Bye-bye, bye-bye, bye-bye.